So what I'm going to present today is a joint work with Francesco Billari, who unfortunately had to go back to Milan today, and Qian, Can you hear me? Okay.
Excuse me. We can hear you if you speak to us.
And not to the slide. I tend to speak to the slide, you know, that's... Oh, thank you. That's true. Thanks. Good suggestion. Okay, so I was saying that what I'm going to present today is this work is joined with Francesco Billari, who's actually, had to go back to Milan, Eric Qian, who's now at the Federal Reserve of New York, and Ingmar from the Computing Qatar Institute. And our idea is to present a way to leverage digital trace data or large data gathered from the web to track culture-based kind of like family change and so and its fertility or general family implications. We start with apart from a very basic intuition. I mean, all of you know about second demographic transition. Is the idea that, and we focus on the idea that is nicely gathered in these Google Books graph. Is basically that as the second demographic transition progresses, more people transition to parenthood without passing through traditionally gendered family roles like being wives or husbands. And you can see that then the coupling happens exactly when we expect it to happen. And then our next goal is to see whether we can track the coupling on using basically digital trace or web data. And in particular, well, this is the idea, okay, is that goes back in sociology to Goffman, and people present themselves every day, and of course the online world also kind of like is a venue where people go and present themselves, and we are going to leverage that, especially how people present themselves online, to gather identities related to family. Why Twitter? Okay, we have 300 million monthly active users. This is one of our co-authors, and on Twitter, of course, we showcase a lot of our life, and the idea is to exactly tap into that to count how many fathers and mothers or relative to husband and wives are there in the US population. So in order to do that, we use a website, it's called Triangulate, which allows us to use Boolean operators to look for specific users based on keywords and locations. And of course, we look for specific keywords, which are father, mother, husband, wives, and so on, colloquial terms. So this is how kind of the code looks like, and you can see it is based on the US. So we look at all the states of the US, and specific terms that I just mentioned. We retrieve, so we run this code. We ran this code every month last year, and then also in 2016, to scrape the Twitter bios of many users. And you can see this is what we're looking at. Exactly this self-description that you have online. You may, if you have a Twitter account, think back, what did you write there? This is how you present yourself. Maybe you are like in control or not, but that's what we look at. And we found that it's relatively stable. We don't have to look at computational intensive ways of looking at thousands and thousands of tweets. People present themselves in some way. For example, Barack Obama in this case is in our sample because it defines himself as dead. So we can, oh my God. So we actually gather him in our sample, and then we have the location. And the idea is to have time and space. So this is the output. It's a long string of users, their followers, their username, their location, and the keyword. Of course, there's also some false positive, professional sugar daddy. This guy is also in our data set. So there must be ways to actually get rid of these people. So there's a lot of work in order to, people can get very creative, so in order to actually have a clean data set, and we start from a 5.4 million users, and then we clean it by location, by description, also manually, so it's quite intensive, and then we get around 500,000 observations, like users per month, or 2.5 million observations. As I told you, like there's not a lot of variation in this month, so the next idea is, okay, this is a bit of descriptive. So you can see that from our Twitter sample of 2.5 million, you can see that we have twice as many mothers as fathers, so not as such, and then we have, as you can see, mom and dad, you know, so there's many women, way more, relatively more women describe themselves as mother than men, and then the next idea is to basically compute these kind of prevalences. So we want to know how many parents are there, meaning people who describe themselves as father, mother, etc., relative to husbands or wives. And this kind of looks like psychodemographic transition literature, you know, results, right? So we look at the coastal states, we have relatively more, the ratio is higher, and in Central, you know, Middle America, the ratio of father on husbands and wives is actually lower. This is also can be seen as simple kind of linear correlation with Cronley-Sage's psychodemographic transition principal component analysis, gathering 13 different variables, real kind of like census or survey variables, and you can see that basically we are onto something. So even with our non-representative digital trace data sample, we still can kind of track things that are happening in the population in terms of family identities, or in this case, demographic transition. So the next thing that is interesting with this data is that you can kind of, if you believe that SDT is about culture change, you can kind of leverage this bias to track also, to operationalize culture, because we don't only have, you know, self, you know, identity in terms of husband with Tim Flowers, or on the left side, or mothers, but we also have a bunch of other words that go together in the bio. And you can see here, thank you, you can see here that these two identities are very different. One could be considered more traditional, and the other kind of like more complex. And so our next idea was to use all those other kind of like cultural items that go together to track whether, you know, different stages of the second demographic transition. We also see different kind of like cultural composition of the family identities. And you can see here, so for example, the state who kind of like scores the lowest in the second demographic transition, and the states who scores the highest by looking at our sample for wives or for women. You can see, for example, that words like Christian and God and words related to religion kind of like disappear at the highest state of the second demographic transition. Of course, this might be just state fixed effect, but with a sample, and this is time and space, right? And how to disentangle these two factors. Our idea is that with a sample or a panel of repeated observation, we can actually tap into this disentangling question. And then by basically vectorizing some of these words, we can simply plot, you know, for example, on the left, we see that when we kind of lump all the religiosity words together as dummies, as one or zeros, and then we plot the probability of observing them related to words like, for example, mother or father, as a function of the second demographic transition, we can see a decreasing probability of observing a parent who also is religious, and at the same time, you can also see an increasing probability, for example, of observing a mother who's also working as a scientist or in STEM. So this is basically just a proof of concept to show that, you know, these kind of change go together, and we can measure them using this data. Another thing, for example, is that we also have an increased possibility of observing a parent who defines him or herself as a feminist as the second demographic transition progresses. And you can see this is only positive, so we can see it goes almost to zero at the lowest stage of the second demographic transition, as gathered from PCA restacking indicators. This is just because we're using a sample for parents, or while if we went to the overall population, we may also have negative kind of probabilities of observing, feminism and parenthood. So the idea is that this kind of speaks to a diffusion argument as well. So if it's cultural change, we could, by using Twitter data or like Facebook data, look at the diffusion, and our first kind of attempt is, for example, to look at followers. So, for example, do mother or father, or relative to husband and wives, have different amount of followers? Is simply kind of naive kind of diffusion based on the size of the network argument. And we don't really observe a lot of that, but we do observe, we do observe that, for example, there is also in this case kind of like a male premium, like fathers and husbands have consistently higher number of followers compared to people who define themselves as mother or wives at both lower and higher stages of the second demographic transition. So, to conclude, we claim that using this digital trace data might be useful to analyze culture-based demographic change, or at least partially culture-based demographic change, without imposing stronger priori kind of theories, as people go online and decide what to write. We use Twitter to track these differences. Okay, yeah, I'm done. And we also show that actually our measure is kind of reflects on kind of like ground truth data that we have from survey and censuses. For the next step, of course, we would like to disentangle better the question of time and space using this panel, as I mentioned, and also, of course, there's a lot of computational work to do just to understand how to kind of automatize, the cleaning and the filtering of these data, which are very noisy. And then, of course, the idea is that if we could extend, and this is now for the US, it's easy because it's in English, but then I think there might be, and the population is kind of like relatively uses Twitter a lot, but then the idea of to extend it to a global scale and different stages of the second demographic transition might be, and to other behaviors as well, might be a promising way of tracking cultural and demographic change in this kind of in the future, let's say. Okay, thank you.